China's declared that they're building 450 nuclear power plants. The net effective cost of electricity production out of a nuclear power plant is somewhere between 1 and 5 cents per kilowatt hour. The US on average is paying 11 to 15 cents per kilowatt hour.
American scientists are absolutely shocked by China's latest nuclear reactor breakthrough, which could completely change the future of China and our entire planet. China launched its first thorium molten salt reactor in one of the world's hottest and driest regions, the Gobi Desert. The expanding desert is known for challenging the local population of the entire region with extreme weather conditions and brutal sandstorms. But now, it is witnessing the dawn of next-gen nuclear technologies with China's latest nuclear project. While traditional nuclear plants use more than a 50-year-old technology based on uranium, thorium is the future and game-changing for several reasons. With only 1 ton of thorium, it's possible to generate the same amount of energy as with 3,500,000 tons of coal. Thorium reactors can burn nuclear waste, operate in dry and hot areas, and pose no risk of dangerous meltdown situations, making them a revolutionary, clean, and safe nuclear alternative. But China built this advanced new reactor because of its abundant thorium reserves. And by tapping into this resource and harnessing the power of thorium, China is about to discover the technology that will give it an unlimited clean energy supply for the next 20,000 years. So what is this thorium reactor all about? How did China build this advanced new reactor? And what does it mean for our world? We've got all the details you need to know right here. Did you know that the United States was the first to discover thorium nuclear technology? Scientists of the Oak Ridge Laboratory built a molten salt reactor in the 1960s that proved the practical use of thorium. However, the development of these reactors was hindered for a few reasons. One reason was low military interest. Molten salt reactors are not suitable to produce weapons-grade enriched plutonium and uranium, which are needed to build nuclear weapons. A deterrent nuclear arsenal was indispensable for the US during the Cold War with the Soviet Union, so the thorium reactor has never made it to commercialization. But as it turns out, molten salt reactors are an excellent option for clean and safe nuclear energy generation. However, thorium is a low radioactive material in its naturally occurring form, so it is unsuitable for nuclear fission and must be transmuted in a thorium fuel cycle. The fertile isotope thorium-232 is transmitted into thorium-233 by absorbing a neutron of an external neutron source. A thorium molten salt reactor can integrate nuclear waste by using the highly radiotoxic plutonium and other actinides from spent fuel to kickstart the reactor. As the reactor operates, it not only produces energy, but also transmutes nuclear waste into less problematic isotopes. Simultaneously, thorium in the reactor is converted into fissile uranium-233, further fueling the reactor and generating energy. In essence, the thorium reactor can extract energy from both thorium and nuclear waste while reducing the radiotoxicity of the waste. India accounts for 25% of the world's known thorium reserves and is home to the world's largest natural thorium supply. Therefore, they introduced a 3-stage nuclear power program in the 1950s. This nuclear program should secure the nation's energy independence and supply its massive growing population. However, due to economic, technological, and infrastructural challenges, there were massive delays in the energy program. Developing a new reactor technology requires not just research, but also infrastructure, training, and a skilled workforce. And this is where China has some major advantages. But first, we need to understand the link between thorium and China's control over the rare earth supply chain. Thorium is a byproduct of the rare earth mining industry, and China is by far the largest producer of usable rare earth metals, accounting for 60% of rare earth mining and 85% of rare earth processing. Raw materials such as cobalt, nickel sulfate, lithium hydroxide, and graphite are predominantly sourced from mines in South America and Africa. But a significant portion of these raw materials is sent to China, where it controls the refining process to create battery cells for the rising EV industry, thus giving the country a significant supply of thorium. This is the main reason why China relentlessly pushes the construction and commercialization of thorium reactors, as it has the potential to give the country unlimited energy by leveraging its thorium supply. However, with China's goal of becoming carbon neutral by 2060, the thorium reactor is just one part of its bigger nuclear program. The nation invested a whopping $440 billion in its nuclear buildup and plans to build at least 150 new reactors. That's more reactors than the rest of the world has built over the past 35 years combined. But the thorium molten salt reactor is revolutionary for several reasons. Unlike traditional nuclear power plants that require water for cooling, this reactor doesn't need any water. The thorium is dissolved in a molten salt mixture, giving the reactor its name. The liquid molten salt fuel acts as a natural passive cooling system. If the reactor gets too hot, the liquid fuel expands, slowing down the reaction. This natural feedback loop helps to keep the temperature in check, making it suitable for construction in dry and arid areas such as the Gobi Desert. This feature makes this new reactor type particularly interesting for China to power its Belt and Road Infrastructure project in off-grid areas without access to water supply. However, because of rising temperatures and ongoing droughts, this will be an increasingly important feature in other regions of the world. For instance, France, the biggest nuclear energy producer in the EU, had to cut its nuclear energy output as the river's water heated up too much during the heatwave season and couldn't cool the reactors down, and a winter drought made it even worse. The nation, which traditionally exports energy, had to rely on energy imports for the first time in 40 years. That's the type of problem the thorium reactor solves. Another exceptional feature of this new reactor is its ability to burn uranium-238, the toxic nuclear waste produced by conventional nuclear reactors. As nuclear nations are struggling to solve the repository problem, China can use its new thorium reactor to convert nuclear waste into clean, carbon-neutral energy. Additionally, the technology is considered extremely safe, as the reactor can regulate its temperature itself to avoid dangerous meltdown situations, as happened in the past in Fukushima and Chernobyl. That's because molten salt reactors are designed with a built-in safety mechanism. At the bottom, there's a freeze plug, which is a section kept solid by coolers. If the reactor overheats, the plug melts, and the liquid fuel drains into separate passive cooling tanks, where it cools down safely. With this new reactor type, China marks a new milestone and takes the lead for advanced nuclear technologies. By connecting these new reactors with its huge wind and solar farms, China will have a baseload-capable renewable energy grid and be the world leader in green energy production. But how did China build this reactor so fast while other nations are lagging behind? One reason is that China's one-party governance allows long-term planning and fast decision-making. Being a one-party system, China can streamline its investments in infrastructure without any bureaucratic hurdles which would slow down the process. A testament to this efficiency is China's high-speed rail project. After deciding the construction, it was up and running in just a few years. China plans to export its new reactor type along with its Belt and Road project and build 30 new reactors by 2030. With its abundant thorium supply and new thorium reactor technology, China is about to leverage another type of technology, as it has the potential to change the world for a few reasons. The biggest factor is the increasing importance of clean, carbon-neutral energy in the global economy. Conflicts like the Russian-Ukraine war led to a massive surge in energy prices and showcased how reliant European nations are on Russian energy. The thorium molten salt reactor would be a perfect alternative to decouple from Russian gas. Additionally, it is a carbon-free energy source which is in high demand and a safe and clean alternative to conventional nuclear power plants. However, nuclear fusion is another carbon-free energy source and considered as the holy grail of energy for more than 50 years. Scientists weren't able to harness this type of energy until now. German scientists have made a major new breakthrough with a new fusion reactor design that was only possible with the help of AI. Click on the displayed video to learn more and subscribe to this channel so you don't miss anything in our ever faster evolving world.